I'm Won Lee. I just started Chapter 5, Test Hypothesis. And today's topic is test statistic and rejection region of null hypothesis, say H0. Okay, let's see previous lecture. Okay, test hypothesis, null hypothesis, and alternative hypothesis. So null hypothesis is shortly H0. Alternative hypothesis is shortly H1. Okay, what is an alternative hypothesis? Alternative hypothesis is the contents of new claim, and that is of interest, and contents that differs from previously known information, something like that. And contents of a null hypothesis is typically established as the opposite of alternative hypothesis. You get it? Okay, let's see. Today, test statistic and rejection region of H0. Since hypothesis is a description of parameter, okay, in statistics, best statistic or estimator corresponding to that parameter should be used. Okay, this is referred to test statistic. There is terminology, test statistic, new one. In estimation part, the term estimator is used, okay, for statistic, best statistic. While in hypothesis testing, we call that estimator as test statistic. So same thing. Say X bar, for example, X bar is estimator in estimation part and test statistic in hypothesis test. Furthermore, when the value of a test statistic falls within a certain range, the null hypothesis is rejected. This range is called rejection region of H0. Null hypothesis is rejected when the tested statistic falls within a certain range. So we like to get rejection region of H0. All right. Let's consider example of a biased coin. Yesterday, I took this example. There is a biased twisted coin. Okay, then for that coin, the probability of heads coming up is not 0.5 because it is biased. So H0 in that time, probability of a head and probability of tail are equal, H0. But H1 is new claim, your claim, because the coin is biased. So H1 is PH is not equal to PT, right? We call this kind of a thing as a two-tailed test. We concentrate on two-tailed test here first. Okay, how will we perform the hypothesis test? H0, H1, H1 is what? H, probability H is not equal to probability of tail. That is H1. First, what will be the test statistic? How to test it for this problem? You may toss that biased coin many times, okay? Then you will decide, okay, this is biased so that the two probabilities are not equal or equal, right? So, for instance, let's say we toss 100 times. What is it? It's simple, okay? HT, you toss 100 times, then the coin result tail, head, something like that. In this case, the test statistic will be the number of times heads comes up. Okay, how many times has? How many times has? Okay, so if the number of heads observed after tossing the coin 100 times is either very low, small number of heads, very large, many number of heads, then you what? You will decide, okay, this is biased, so we reject H0, null hypothesis. In other words, two probability of head, probability of tail is not equal, right? Very low or very high, right? And we would conclude that the probabilities of heads and tails are not equal since the coin is biased. This is hypothesis test. In other words, test statistic is X, which is what? Number of times heads comes up. Number of times heads comes up, or tails comes up, the same thing in this example. And the rejection region for H0, for rejection region, H0 is two probabilities are equal, okay? Rejection region. We reject this one, H0, then in other words, we support H1 is not equal. Would be the rejection region for the null hypothesis will be X less than 50. 50 is criterion. 50 minus some value, or X greater than 50 plus some value, right? That is a small, this area range is very high. Okay, if heads comes up 52 times or 48 times, then can we say that the probabilities of heads and tails are not equal? No, because if you toss 100 times that coin, or a coin is a fair coin, okay, normal coin, then 50 times head number of heads can be 52, or number of heads is 48, not exactly 50. So there is just some buffer range. So we like to get this value. That is rejection region of H0. Okay, let's see example continued. Regarding a biased coin where the probability of heads coming up is not 0.5, then the H0, H1 is something like this. You may say, okay, pH equal to 0.5. pH is not equal to 0.5. Same thing. And is say sample size is 100. Test statistic is what? Number of heads, X, number of heads. Rejection region of H0 is X minus 50, sorry, X less than 50 minus some value. We have to decide this value question. And symmetrically, X greater than 50 plus that value. Okay, this value, same value here. When a claim is made that the waiting time at a certain counter is more than average of 5 minutes, then this one, question is this one, mu greater than 5. And H0 is just what? The other area, mu less than equal to 5. But you may think this way, mu equal to 5, except less than. Okay, that's okay. That's okay for beginner or for you for the introductory course. Test statistic is what? The best estimator of mu. Best one, X bar. We have to use X bar, right? Rejection region of H0 will be X bar greater than 5 plus some value. Double question mark, right? This one is mu greater than 5, so X bar should be 5 plus some value. Double question mark, okay? If X bar equal to, small X bar, realized value obtained, equal to 5.001, then can you reject H0? No, because it is very close to 5. So you cannot, if you get x bar, value of x bar, 5.001, you cannot reject H0, right? So it is a small value, not big one, but we have to decide, we have to get this double question mark value. In case of a hypothesis testing regarding the claim that lifetime of a certain device does not reach 2,000 hours, okay, this is a claim. So what? This one should be H1, alternative hypothesis, mu less than 2,000. The rest of the area in real number is H0, like this. But you may use mu just equal to 2,000, okay? Yeah. For simplicity. Test statistic, it is what? Test hypothesis about mu, so test statistic is x bar. Rejection region of H0 will be x bar less than 2,000 minus triple question mark. We have to know, we have to determine this triple question mark value, okay? See, equal sign is in what? H0. Since testing hypothesis has assumption, under the assumption, the null hypothesis is true. Okay? Null hypothesis, contents of null hypothesis is true. Based on that kind of assumption, we, continue the test hypothesis process. Okay? Okay. This is a real simple example. These are simple examples for you to understand test hypothesis. Okay. Today's lecture is up to here. Thank you. Bye.